So we're going to talk about FHIRPath. So if you're not coming for that, you're in the wrong room. And as usual, I think I have more slides than I have time, so let's get started. My name is Ewout Kramer. I work for a company called FHIRPath. And part of my work, when I'm not working on the FHIR specification, is building software, because I am a software engineer. And for example, I developed the .NET API, and also I've been involved with a few more people in designing the FHIRPath language. So I'd love to tell you a little bit about FHIRPath. The FHIRPath itself, it has a rather lengthy specification. So what I'm going to do for you is do kind of a 101 ending in a 102, or just showing you the basic highlights of FHIRPath. There's much more to tell, obviously, than I can do in 40 minutes. Switch the batteries. This works probably. I can attach it to my beard. Nose, hair. Well, so I guess this is slightly better. So just keep it like this. Okay. So FHIRPath. If you go to the FHIRPath specification, and what I'm showing here is hl7.org/FHIRPath. So the first thing you'll notice is that it's not physically in this path part of the FHIR specification. And there's a reason for that, and that's because FHIRPath, although it's called FHIRPath, works on any kind of data model, not necessarily FHIRPath. And in fact, it's used on other data models. If you go there now, you get to the STU1 release, which is standard for trial use 1 in specification people speak. And that means that this is just to try out. And we had a lot of feedback on the specification. So we're now working on a normative version, which has probably many of the problems in that current spec ironed out. But that's still not an official release. So the official release here is FHIRPath STU1. So if you look at that specification, it says that FHIRPath is a path-based navigation and extraction language, somewhat like the XPath. Now, you might wonder, what is that extraction and what is navigation? I'll give you a few examples of why where in the spec FHIR is using FHIRPath and why maybe you will be using FHIRPath. Many places in the FHIR specification, we needed a way to point to some point in a resource instance. So for example, FHIR allows you to define new search parameters server-side, but then you have to indicate which field of a resource you're searching on or indexing. So you need a way to point to a point in an instance. And in XPath, you can do that on an XML document. You can say, go to this in the XML, select all nodes in this XML document. And we needed a language like that. Also, and you can do that too with XPath, we needed a language to formulate business constraints. Like, upper limit should be higher than lower limit, which is easy to express verbally, but we needed a language to express that, not being like C# or JavaScript, a language that was neutral to domains. And so that's why we came up with FHIRPath, basically for both of these two uses. And so if you would use FHIRPath now yourself, you would do it because you are defining, you're creating an implementation guide and you want to put additional constraints like the ones I just mentioned on your data. Or you would define, if you would be defining new search parameters. So the two main points is defining new search parameters and against the model and structure definition, which defines business rules more or less on FHIR data. Or, and that's what I'm using it for as well, extract data from an instance, for example, narrative generation. So you could say, here's a patient, I want you to run these FHIRPath statements on it and concatenate that in a text field, and then I extract basic patient information and turn it into some piece of text. So FHIRPath is an extraction and a language to formulate business rules. So it's not a language which you can use to update any data. So if you have a patient, you can't use FHIRPath to say, change this bit into that. You could point to that bit in an instance saying all family names of this patient, but you couldn't say, now remove them. It's not what you can do. FHIRPath is a pointing facility in that sense. And as I said, it works on other types of data too. So though it's called FHIRPath, it's not specific to FHIR. One of the languages it's used inside in is CQL, which is a language to define clinical decision support rules made by the clinical decision support group, and they needed a language like this. So let's start with navigating data. I informally introduced navigation of data, but I'll show you a concrete example here. So here on the left-hand side is a bit of XML that is an actual patient resource. It has 2 names and a bunch of use, family, and givens, and so on. And on the right-hand side, you see that same XML data represented as a tree. Now, this tree is important because that's the mental model for FHIRPath. It's not like rocket science. As you can see, for every repeating XML element here, there's a repeating node in the tree, and every node, I can even point, and every node has a type, like human name, and maybe a value. So for the more complex things, like human name, there's no direct value because there is like use, family, and given, but given itself is a string, and this has the value Gert, Wouter Gert Kramer, which is my birth name. And surprisingly for many people, of course, is that also in FHIR, something like a primitive, like a Boolean active, can be extended. So primitives have extensions here. So it's a one-on-one representation. But the FHIRPath statements we're going to talk about, they're not XML or JSON specific. In fact, they're not specific to any model at all. So we need to represent, as long as you can represent your data in a model like this, you could run FHIRPath on top of it. And in fact, I think both the JSON and the .NET implementation of these represent data internally like this abstract tree and then run FHIRPath on top of that. So if you write this mapping for whatever you have on the left-hand side, so for example, JSON here, as you can see that XML and JSON, nothing changes on the right-hand side. It's totally format independent. That's important to realize. We're navigating against, FHIRPath works against this this tree. Okay, so if that's clear, then let's do some navigation. I'm going to show you an actual FHIRPath statement. What we're going to do is navigate through this tree. And the obvious thing to do is use patient.name.given. So given a patient, you do patient name. Oh, there are 2 of these. And then for each name, go to its given. So that's here. And like this, we have pointed to a place in a FHIR instance. So now, if I'd run this, if I pass this bit of data, this patient that we had in XML or JSON, to a FHIRPath engine and presented the engine with this bit of FHIRPath, it would return me these givens right here. So this is, it seems pretty obvious, but as you can see, the root actually has no name. And so what we've done here is said, well, the first part of a bit of FHIRPath, you can mention the type. So saying, if I'm having a patient, move down the name and move down the given. But you could have said just name.given as well, and that would have worked too. Now, I skipped one step here on purpose. What now, patient.name.given, what now if this second name here also had givens? It probably has. Patient.name.given would actually saying move down name, okay, there are 2 names, and then return me all givens of all the names that I had from the previous steps. So this would have given you not only these given names, but also any given names for this second name node. So collect all names, and then from all names, collect all givens. That's what this piece of FHIRPath is saying. That's one way to navigate exactly by name. That's the most common one. But we can also navigate by axis. XPath used the term too. We can, for example, navigate by child. Say patient.children. That's pretty obvious. Select all children belonging to the patient node. Patient.descendants would select everything under patient. Just as, patient.name.descendants would select anything here and anything under there except the stuff under active. And then you can combine it and say combinations. So combinations like patient, all nodes, and then navigate into use. So the only thing that would select, well, it would look at all these nodes here, also the ones under here, and anyone all there, and say which of these have use, and then select those. So in this case, in this picture, this is the only node selected. Okay, that's excellent. Just checking how we're doing for time. So now we know a few ways of navigating down this tree, but we have a few more for you, because now it's either you select exactly one or you have all children. But there's a few more functions we've introduced in FHIRPath to navigate to a node. And one of them is by index. So anyone developing in any kind of software language, this looks familiar, but be aware in this case that it's, at least if you're working with Fire, it's 0 based. So you're selecting, this is name 0, this is name 1. So you're saying patient, name, actually patient.name selects all names, and then you're saying give me the second one, which is this. The second one. It makes total sense if you're working 0 based, otherwise it, maybe more interesting, patient.name.last. So patient.name would select all these names, but I only want the last one. Okay, that's fine. So selecting the last one, dot given. Okay, that would be these two. Dot first. Okay, only this one. Now you start to get a feel for this. Like this, you can navigate quite freely through the tree. But wait, there's more. Patient.name.given. Well, that's what I told you. If multiple nodes, patient.name select all these names, and then given would select all the givens of all these nodes. Fine. Patient.name.given.tail. Subtle change here. Look on the right-hand side. It's just the red box is moving one down because its tail is selecting all the nodes except the first one. And then there is patient.name.skip1. Let's see what happens there. Ooh, patient.name. Yep. Skip 1. So don't look at this one. Oh, I think this would be, this is patient.name.given.skip1. Take 3. There's a mistake here. Sorry, patient.name.given, selecting all the givens, skip the first one, so not this one, and then take 3 of these nodes. If you'd read the Fire specification very precisely, you see that I'm lying a little bit here, because it's an implementation detail whether patient.name.given, selecting all these given nodes in which order they will be returned. So skip 1, take 3 would, possibly return a different set depending on the FHIRPath engine that you are using. All of that is documented in the beautiful Fire specification. It's really well hidden, but yeah, it's there. So far I've been talking about nodes, and then it makes total sense that everything is a list. I'm selecting name, but there might be multiple names because many fields in Fire are repeating, so you would return multiple names. And because you really never know whether you're returning 1 or the instance has 3 or 5 or 10, we decided that in FHIRPath, everything is a list. So, let's see. Everything is a list, and every function, everything you do, returns a list. So patient.name could be multiple that count, seems to make sense. But if you know patient.active, there is only one field active, count sounds a little bit weird, but the FHIRPath engine doesn't care. So it doesn't really know whether something repeats like patient.name or whether patient.active, by its definition in Fire, there's only one. It sees both as a list. This is a list of names, this is a list of active elements, but we know there can be only one. So you can do anything with these list operators, patient.name.first.count, but also patient.active.first. There is no difference from a FHIRPath perspective. Everything is a list. And once you understand that, maybe the next ones also make sense. 1.count. Everything is a list. So even a constant like 1 is actually a list of one thing, the number 1. And if you're counting that, it returns 1. So maybe I should have put 3 here, because 3.count is 1. And this is a collection with just the integer. When we go one step up, 1 plus 2 dot count. Well, this, of course, is a single number that you count, so that would return 1. But 1.2, the plus operator in FHIRPath, surprisingly works on lists. It expects a list of numbers on the left-hand side and a list of numbers on the right-hand side, and does a plus. In fact, it demands, if you look at the plus operator, that it would only accept a list of one element on the left-hand side and a list of one element on the right-hand side. If you have multiple, it would barf and throw an exception. So internally in FHIR, logically at least, everything is a list. No special logic for sets or single instances. This is a bit surprising now and then, but it kind of makes sense once you start working with it. You don't have to worry about something repeats or not. What this last line would return is would always return 1.
Is it 1 or is it a list containing 1?
It would return a list containing 1 because everything is a list and every function returns a list. So you're absolutely right. Count would return. So if this count wouldn't be here and I would just have said 1 plus 2, the result is a list with a single element 3. And so for these constants, it's kind of weird, but in this domain where you're dealing with actual paths, it's less weird. So this is all I wanted to tell you about how you point to something in a list, how you navigate down a tree and say, I want to move here in this instance. That's good for extraction, but most of the time then you want to start saying things about it, like this element should be larger than that element, or if this element exists, then that element should exist. So just having paths doesn't bring us a lot. We need operators, comparators, and so on. So sure, there are patient.name 0, that's a path like we just looked at, equals my first name, Ewout. Or patient.name.count should always be less than 2. Maybe my system only supports 2 human names on a patient. So I could formulate a constraint saying, I know the FHIR specification allows you to have like a zillion patient names, but I don't. So I add this business rule here. And so this is kind of a predicate. And we use this in structure definition to add extra business rules on top of the very general FHIR specification. These are expressions returning a Boolean, and you can read them like, this element is considered valid if patient name is Ewout. Patient.name.count is smaller than 2. That's how these are used in structure definition within the constraint element in structure definition. There's some subtleties there that I won't get into, but so we have the usual operations. And or, XOR, and implies. Well, implies is not so usual in many languages, so I have an example of that later. Comparisons, string manipulation, substring, start with, end with, most of the things you would expect. You can do regexes, matching, and so on. And since everything is a list, of course, there are list operations like superset of, subset of, in, and contains. And finally, the immediate if. Most developers in functional languages are completely customized to this, completely used to this, but this is an if statement that's actually returning a value. So if patient.name exists, return yes, and if it doesn't exist, return no. So this is, you can kind of create conditional outputs in your FHIRPath statements. There are tons and tons more of operations in the FHIR spec, and I'm sure that the normative edition coming out this year adds a lot more stuff. Most of the FHIRPath engines allow you to add additional functions to the list that we have. So everything is a list. I think I made that point clear. Yeah.
So the engine runs on top of like the REST API?
Sorry, what?
The engine.
Yeah.
Does it run by using the REST API? So like when I'm sending a query of FHIRPath from a client, how it
Okay.
translated?
Yeah. So does FHIRPath? Is there a REST like interface where you can? No, it's actually used inside structure definitions. And that is used by the validate operation in FHIR. So if you're using the validate operation to validate a FHIR instance against the structure definition, then inside that structure definition might be rules in XPath, so in FHIRPath. So FHIRPath statements alone you can't execute them all by themselves. Though at the end of the slides, I have a list of engines that and libraries that you can download to play with them. Eric.
If you go back to the last slide, one quick question. You had for Ewout.
One back.
You have the parentheses 0, and is it implementation detail where you don't need that? Because I know that when I've used it, I think you have the index for.
So why would you use this index?
Well, index is a list, but is there other implementation details where you don't need it? It's only a single element.
So let's get to that. That was actually where I was going with this slide. So, Eric, perfect. Patient name 0 dot given, but that was okay. Yeah, you're right. Yeah. That comparison will work. No, we have no comparisons for complex types, except now maybe for quantities in the new fire spec. Okay, everything is a list. So let's see what that means for using comparison operations. So patient. Oh, here it's correct. Patient.name 0.given is Ewout. And patient.name given is Ewout. If you know there is only one name, that last statement is like clean, but there is a chance if there are multiple names that what happens? So the first one would always keep working because you're only looking at the first one in the list. But what happens if there are actually multiple names or there are multiple givens? Oh, that's the question. So what happens when patient.name count is larger than 1? Is that an error? Is it false? The answer is it's false, because what you're doing is comparing a list of givens to a list of strings with just one thing in it, and that's Ewout. So they're not the same, because the list on the left-hand side, if there are multiple givens, has multiple items, while the list on the right-hand side has one item. So equals here would return false. Now, some of the implementations of the FHIRPath engines at compile time, so to say, they say, hold on, this is dangerous. We know name can repeat, so this is probably not what you wanted to say. And so we can help people avoiding these kind of mistakes. And so another thing that could happen is that you've written patient.name.given concatenated with patient.name.family, giving a nice Ewout Kramer. But what happens if one of the two repeats? Anyone? An idea? Well, it's just like with the
Does it always do the first?
Right, what would it do? It's like if I do 1 plus 3, or if I use the addition operator and there is more than one thing in the list, this would actually give an error in saying, hold on, all these simple operations like plus and concatenation only works if the left-hand side and the right-hand side contain only one thing. So the fact that everything is a list is helpful most of the time, but you'll have to be a little bit aware. But if you have been working with XPath, you actually were very used to these consequences, because XPath has some of these surprising features as well.
When you say only one thing, that means the size has to be the same?
Where? Sorry.
You just said that this would not work because both have to be the one thing.
So this works if this has one and this is one item. So if there is a patient name with one given and one family, this would be perfectly fine.
If let's suppose given as 2 values and family as 1, it would not.
Yeah, if this had 2 and this had 1, it would just break. It would throw an error. Of course, if you qualify it with zeros, then it would all work again. But there's better options than that, but I'm going to show you a little bit later. So far I've been cheating a little bit on you, because I've used the numbers and I've used strings. So as you can see, FHIRPath is a type language, so I want to go shortly into the type features of FHIRPath. We have a few data types, as you can see, a Boolean here, a string, and of course numbers. And this is the whole list. And the way you would write a constant in them. So strings surprisingly have single quotes. Datetime starts with an add and a timestamp, and there is now a quantity in which you could say 4 kilograms, 4 days, 10 milligrams, and so on. So yeah, FHIRPath is a type language. So comparing stuff, so if I would guess given 0 is active, even if my first name would have been active, that would fail. I mean, there are languages that auto-cast and convert that for you. FHIRPath is not such a language. So there is also a mapping from FHIR data types to FHIRPath types. So anywhere in the data model of FHIR, something is an integer, unsigned int, or positive int, it's considered an integer in the FHIRPath. This you couldn't find in the FHIRPath specification because this is language specific and FHIRPath can be used on any language. So this is actually copied and pasted from the FHIRPath appendix of the FHIR specification. The mapping for the data types to a FHIRPath type would be different for different data models. Like if you were mapping this to a V2 model, which is perfectly fine, or to CQL or any kind of model, different models, you would have a different set of primitives there. A little bit advanced, but I can do it because I'm still running on time. So that also means because the FHIRPath evaluator is aware of types in your instance, you can do the same things that you can do in type languages and say observation.value. I don't know if you know observation.value by heart. Observation.value is defined in the FHIR spec as being one of 7 or 8, 12 types. A lot, yeah. So depending probably on what this value actually is, you might want to trigger some logic. You want to say this business rules only runs if observation.value is a code, and you could do that. There is a FHIRPath instruction called is. So you can say observation.value is quantity would be true if the value is a quantity, or observation.value is ratio, and so on and so on. And you can filter on it too. So patient.descendants, remember that one? That would give you every single element under patient. But you could say patient.descendants of type human name, and you would get, it would filter everything under patient in your instance that is of type human name. That could be a surprising number of elements, especially, well, you could do Boolean here, and it would go into the whole depth of your instance and filter all the elements that are of type human name. So is returns a Boolean, and of type selects the children that are of a specific type. Talking of filtering, so far we've had ways to point to things in instances. We have seen a few ways to compare, but what now if I want to say, well, I'd like to have all patient names that have, where the first name starts with something. That's something we haven't had. So I'm going to show you a little bit how that works. That's the where function. An example is patient name here, where use is official. So what this would do, patient.name, again, is a list of all names, in this case these two here, and it will run them one by one on this FHIRPath statement, and if it matches this FHIRPath statement, it will select the name. So go over patient name by name one by one, that's what I'm saying, and yes, we have one that matches here, and so it selects this name. So that's the trick. You want to select the names that have a use of official. So this is not selecting this node, it's selecting that node, because this is the name where use is official. If I would have said patient.where name.use is official, I would get all patients. In this case, that doesn't make any sense, where use is official. So it depends on this little bit before the where, what you're actually selecting. So that's filtering, and you can go any kind of FHIRPath statement in here. Yep, you could dive into down there under a whole tree. So you could do descendants where extensions exist, and you would get any element that has an underlying extension. You can go all out. So this is an incredibly simple but very, very powerful operation. And that's just selecting things. But sometimes you say, well, now I have my selection and I want to do something with it before I have my final result. And that's mapping. Many languages like SQL does the same. You have the where statement. And then when you get this row of this set of results, in your select, you can still add stuff together, calculate the average, and so on and so on. So we do that with the select function in FHIRPath. It is a function that is run over all the nodes, so patient.name.select goes over name one by one, and then on this name executes this FHIRPath statement. So, given a name with given family, Donald Duck, John Doe, it would produce a list of strings 1, 2, 1, 2, Donald Duck and John Doe. So this is projecting or mapping or whatever you call it. Any language has this, and so has FHIRPath. Trick question. What happens when there is more than one given for one of the names? So we get to patient.name and we run select on given, but that has multiple items, and we try to add it to family. So, no, indeed, error. Yeah, just like the example before, the concatenation operation really requires one argument on the left-hand side and one on the right-hand side. So if given is multiple items, we get an error. What does patient.name.select descendants do? Yeah. So that goes over all names and selects all descendants. So you take, well, we can synchronize still, there's still a patient.name, not too far away, yeah. Go over name and one by one select all descendants. So take all descendants here and everything down there, put them in a list. Take the second name, get all descendants there, and add them to the list. So that's what, the other way around. So the reason I'm showing you this, it is kind of special. When we looked at this one, this looked pretty trivial because you say, I'm going over name and it is given and family and I'm just adding that up. But this is actually answering the question, what happens if this thing, this operation you're putting here and you're running on name, returns multiple items as descendants do? This is called the select many, actually, in many other languages, which means that it would concatenate everything. So name, go over the first one, select all descendants, go over the second one, select all descendants, go over the third name, select all descendants, and put them in one flat list. So that's a flattening operation. Just needed to point you out. If you think, what's it talking about, don't worry about it.
Can you just briefly, what's the difference between that with the select and if you just remove the select and said patient.name.descendants? As far as the results.
As far as the results, there is no difference.
Okay.
Yeah.
Another question, is there any non-flat list?
No. Working with missing data. So we were very happy with our first draft of FHIRPath, and then a guy came along called Bryn Rhodes. He's here, not in this room, but he is, and he said, yeah, that's nice, but what about missing data? So first the problem. Patient name.given is duck. What happens if you say, is this true, if there is no patient name? So this patient had no name, and comparing it to duck, what would you do? There is multiple options what we could do. In summary, what do you do when I'm comparing, when patient.name.given is actually an empty list? This is really the syntax for an empty list in FHIRPath, and compare it to a thing, or compare it to something. Is it false? Or is it, I just don't know? Because I can't say it. If patient has no names, what am I going to say about this operation? And he argued that we should do this. Functions and operators propagate I just don't know, also known as empty. So if you're comparing an empty array to duck, you're not getting back an array with false or true, you're actually getting back an empty array. And if you're comparing empty to 1, you're getting back an empty array. So if you don't know something, if something is empty, and you're comparing or adding or doing anything to it, the result is always empty as well. Well, this is just like SQL. It's not completely true what it said. Let's look at the OR operation. True and true is obviously true for an OR. True and false is still true. Well, that's our, that's the OR we know. And true and empty is still true because, if one side is true and we don't know anything about the argument, it doesn't really matter because the OR is going to be true anyway. But if we have a false and the other one is empty, we can't say anything about it anymore. So then the result is empty as well. So we have 3 valued 3-valued Boolean logic. If you're used to that in SQL, this is no news, but it's something you have to be aware of. So what you'll use quite a lot in this case is an operation like implies. And I think I have an example. Yeah, the lower one. Well, oh, here, no, we'll take the upper one. So you could, for example, say, or did I have it here? Sorry. Yeah. So if you don't want this empty stuff to appear everywhere because it propagates, you could do a few things, and I'm just going to show you the bottom one. The implies operation is really neat for that. If patient.name.given exists, that implies given is duck, which makes this a total different statement from patient.name.given 0 is duck. Because if patient.name.given 0 did not exist, comparing it to duck would return you, I don't know, you know, there was no given name, so I don't know what comparing to duck means. But in this case, if given exists, then compare it to duck would return true and false when we have a given. And if given does not exist, then it's simply true. So this implies operation is pretty useful to dealing with these kind of things. The best thing to learn FHIRPath, though, is we've used it everywhere in the FHIR specification to formulate constraints and business rules on our instances. So if you go to any single resource page in the spec, there's a section called constraints, and it has lots of examples of things you can do with FHIRPath. So I've just shown you like the most important ones here, but there's a lot of useful examples. So finally, if you want to try it out, I promise you this page. This is HTTP, well, this URL here. You will get the slides. wiki.hl7.org, FHIRPath implementations. And I'm pretty sure if you Google just this, you'll get this page as well. You'll see a few executables and libraries that you could download to play with FHIRPath, especially I think the Notepad++ plugin or the FHIRPath tester here. You could just paste in an instance in JSON or XML, type a FHIRPath statement, and see what it returns, which is very, very useful. That is the end of our time together. So I'm pretty sure I finished everything. So any questions, come back, visit me, and I'll answer them. Thank you.